Plane shapes. In this chapter, we're going to look at some properties of parallelograms, some of which we've covered in the past. Okay, so here are some plane shapes. The first we have here is a parallelogram, and the properties are as follows. The opposing sides are always parallel to each other. That means they never meet. So this is parallel to this, and this other side here is parallel to this. Okay, that's a very important property. Then the opposite sides are also equal. Okay, so this side equals this side, and this side also equals this side. Then opposite angles, this is opposite to this. Opposite angles are equal also in a parallelogram. Okay, and this angle equals this angle. Okay, so opposite sides are equal. Now the area is also calculated just like a rectangle, the length times breadth, and the perimeter equals 2 length times breadth. Then the next is a rhombus. A rhombus is a quadrilateral. I've covered this before. Quadrilateral, which is a four-sided figure. A figure with four sides. And we say that of 5 sides is called the pentagon. We have hexagon, heptagon, octagon, nonagon, and decagon, up to 10. Okay? So a rhombus, the 4 sides are equal. It's like a square. The opposite angles are also equal. So this also is equal to this. And the diagonals bisect one another at right angles. So let's say you draw a line from here to this side and from this to this. So the angles bisect at right angle. Now the next is the trapezium. We have one here, the trapezium. To calculate the area of a rhombus is written here. Then for a trapezium, have it as half a plus b. This is a plus b times the height. Half a, when you add the two, half a plus b, then multiplied by the height. So add up the two lengths and multiply by the height. And that gives us the area of the trapezium. This formula, they are all very important and they are expected to memorize, have all of them at the back of your head. Then for a circle, we've covered a circle in our past, in the previous chapter, and the area of the circle is given as pi r squared. I've explained what pi is, what r, which is the radius, is also. Now let's look at other figures. We have here a cylinder. A cylinder has two parts. We have a circular top and also the same at the base. Circular base also. Okay. Then the body is made of a rectangle. So just imagine a rectangle running down this way. So this is a rectangle. Okay. Then the area of the cylinder is calculated as the area of the circle at the base, area of the circle at the top, and area of the rectangle. So the area of the two circles, you have that area of the circle is pi r squared. So the 2 now gives you 2 pi r squared. Then the area of the rectangle is given as this height times the area of this circle. Okay, which gives you the width. Okay, so just imagine cutting this cylinder on one side and opening it up like a Milo container. When you cut and open it up, so you find out that it increases. The width equals the distance around this place, and the distance around this place, don't forget, is the circumference, and the circumference is calculated as 2 pi r. So 2 pi r gives us the width here, then multiplied by the height. So that gives us the area of the rectangle. Then the total area equals 2 pi r squared plus 2 pi r h. That gives us the area of the cylinder. Then the volume, I always explained before, every volume equals the area of the base then times the height. So the area of the base is a circle. The area of the base equals pi r squared, then multiplied by the height. It's pi r squared h. Having this formula at the back of your mind, area of base times height equals volume, makes it very easy for you to calculate the volume of any object. Okay, then now let's look at a cuboid. A cuboid, like our matchbox, is a cuboid. The volume is calculated, as you all know, length times breadth times height. Then a cube, like a sugar cube, also the same thing. Then we'll now come to a cone. A cone is the top of a funnel. Okay, this is the top of a funnel. The area is calculated as, first of all, you need to know the parts. This is the height. When you talk of a cone, let me draw a cone standing on its base. This is the height. Then this on this side is called the slant height. The slant height, that is this, or this is the slant height. Okay, so the area of a cone is pi r l plus pi r squared. Let me explain this. The area of a cone is the area of its base, which is a circle, and that is pi r squared. Then plus pi r l. Pi r l is the area of this sector. Remember when we talked of a sector? A cone is made of a sector. So the area of this sector is calculated as pi times r times l. So this is r radius. Then the l is the slant height. Okay. Then for the volume is calculated as 1 over 3 pi r squared h. Okay, so don't forget our previous formula for volume. Volume is the area of the base, which is a circle, then times the height. Okay, so the area of the base is pi r squared. Okay, then the height is this line drawn up to this point, which is h. So you might be wondering, where is the 1 over 3 coming from? Okay, now let's go back to this cylinder. The volume of a cylinder is pi r squared h. Okay, so pi r squared h, there should be h here. Then what is the difference between a cone and a cylinder? So a cone is drawn this way. Okay, so imagine a cone is like dividing a cylinder into 3 parts. You have this first part here, you have the second part, which is the middle, and the third part this way. So that's why we'll have to divide the area of this rectangle into 3. So that's why we'll have 1 over 3 pi r squared h to calculate the volume. So that's how it's divided by 3. So a cone is a rectangle divided into 3 different parts. Okay, then we'll now have our sphere. Our sphere, the volume is calculated as 4 over 3 pi r cube. Now, for now, I want you to memorize this as the volume of the sphere. And a sphere is something like this, like an egg. When we get to differentiation and integration now, senior secondary class, it will be easy for you to understand why the volume is calculated this way, 4 over 3 pi r squared cube. Okay, so I want you to revisit this chapter from time to time to help you understand the concepts, memorize the volumes, how to do all the calculations for the different shapes. Now we're going to take some examples before we move to the next chapter. Okay, so our first example goes this way. A cylinder of height 12 cm and radius 5 cm is made of cardboard. Use the value of 3.1 for pi to calculate the total area of cardboard needed to make a closed cylinder. So we have a cylinder of height. Let's draw the cylinder. A cylinder of height 12 cm and radius of the cylinder is 5 cm. Is made of cardboard. Now use the value of pi to calculate the total area of the cardboard needed to make a closed cylinder. So that's simply as telling us to calculate the area of a closed cylinder. So how do you calculate the area of a closed cylinder? Don't forget, it's 2 times the area of the two circles, 2 pi r squared, then plus pi r. Let's go back to this, then plus 2 pi r h. 2 pi r h. So that's our formula. Now to calculate that, we'll now do 2 times, I thought to use pi as 3.1, then our radius is 5 times 5, okay, then this plus 2 times 3.1 times radius is 5, then the height is 12. So when we solve this, it's easy for us to now find the total area. So 2 times 3.1 will give us 6.2 times 25, then plus 6.2 times 12 times 5 is 60. So when we simplify this, our answer, the final answer should give us 527 centimeter cube. That's our answer. Then we're now told to find the area if the cylinder is open at one end. So if the cylinder is open at one end, what we'll instead do is, instead of using 2 circles here, we'll now remove this pi r squared, remove this 2, and the formula becomes pi r squared plus 2 pi r h. So we'll solve this. So it's still the same principle, and we'll solve it to get the answer. Okay, now let's take another example. How many liters a cylinder can 14 cm in diameter and 20 cm high can hold? Okay, we have a cylinder can. And the properties is 14 cm diameter is 14 cm, and it's 20 centimeter high. And we're told to find how many liters of water it can hold. That seems as telling us to find the volume. Okay, so how do you calculate the volume of a cylinder? Let's go back to our formula. It says pi r squared h, which is the area of the base times height. So we now have pi r squared h. Pi is 22/7 times r is diameter divided by 2. So 14 divided by 2 gives us 7. And times 7 times height is 20. So we'll divide this. We have 22 times 7 times 20, which is 154 times 20, which is 1540 times 2, which is 3080 centimeter cube. Okay, so that's our final answer. Okay, our final example, we'll take if we use the trapezium to demonstrate our final example, and the diagram goes this way. We're told to calculate the value of the side marked D if the area of the trapezium above is 44 centimeter cube. So we're told that the area is 44 centimeter cube. What's the formula for finding the area of a trapezium? The formula is this: half a plus b times h. So we have it at 44, which is the area, equals half. Our A is 10 and our B is 12. Then our height, which is D, is unknown. Okay, so we'll have it as 44 equals half of 22. 10 plus 12 is 22 times D. So we'll have it at 44 equals 2 into D to give us 11, equals 11D. Therefore, D equals 44 divided by 11, and that gives us 4 cm. So our answer is 4 cm. Now that brings us to the end of the chapter. I want you to click on Start Quiz and answer all the questions following.